Hey everyone, welcome back to your favorite YouTube channel, Honors Algebra 2 Lessons with Mrs. Donovan. Yeah, welcome back. Don't forget to like and subscribe and comment down below and all that stuff. Just kidding. I hope that you guys are enjoying your online learning day. We are going to be talking today about operations with radical expressions. So by operations, we mean addition, subtraction, multiplication, and division. While we are working on these, it will probably be helpful for you to have a running list of perfect squares and perfect cubes. Those are the ones we're going to be looking at. And I will try writing them, but my screen is not very friendly lately. So like by perfect squares, I mean like 1 squared is 1, 2 squared is 4, 3 squared is 9, 16, 25. Just have a list of like maybe up to like, I don't know, something, maybe 10 squared, 11 squared, 12 squared, stuff like that. And then also having a list of perfect cubes, like 1 cubed is 1, 2 cubed is 8. Sorry about this, the quality's not great. 3 cubed is 27, 4 cubed is 64. If it's not, oh my goodness. Okay, you get the idea. 5 cubed, 6 cubed, so on and so forth. Just having kind of a list close by while you're working might be helpful. So before we get into operations with radicals, let's just talk about a few basic properties. If I have the nth root of a times b, then I can separate that actually into 2 radicals, the nth root of a times the nth root of b. We can also go from this side to the other. So a lot of times we'll be combining these into a single radical expression. So for instance, square root of 12 times square root of 3 is just square root of 36, which is just 6. Cube root of 4 times cube root of 16, so on and so forth. Same thing with division. If I have a fraction inside a radical, I can rewrite that as the nth root of a over the nth root of b. So like here, we can separate these two, and then it's a lot easier to take the square root of each of these individually, or the cube root of each of these individually. Okay, so those are some of the concepts. Now, another thing that we're going to be doing here is we're going to be putting all our answers in simplest form. So a radical expression is in simplest form if the index n is as small as possible. So the root, square root, cube root, so on and so forth. The radicand, the part inside the square root, contains no factors other than 1 that are the nth powers of an integer or polynomial, and we'll talk about that. The radicand contains no fractions, so no fractions inside square roots for simplest form, and then no radicals in the denominator. So when we are simplifying these expressions, again, I'm going to use the examples in the book, so these are on page 333 is where we're starting. However, and if my screen was writing better, that would be a lot easier. But I'm going to do these my own way because I think the book makes this way more complicated than it needs to be. So we're going to look at example 1, but I'm going to start with 1b because you guys are mostly familiar with square roots. So I want you to think of it this way. When I'm finding the square root of this expression, we're going to start, and we want to just simplify this expression. We're going to start by simplifying the radical, square root of 75. And I think you guys are familiar with this now. 75 is the same as 25 times 3. And this is why I say keep a running list of perfect squares, because if you have a number, you want to think of factors of that number that are perfect squares. So if it has no perfect square factors, like for instance, 71, there's no factors of 71 that are perfect squares, so we couldn't simplify that. But if a number has a perfect square as a factor, then we can simplify it. So 75 is the same as 25 times 3, square root of 25 times square root of 3. So I can rewrite this as 5 square root of 3. Now x to the 12th, we said that we would just divide 12 divided by whatever that number is, which again, when it's not there, is just 2. So 12 divided by 2 would be x to the 6th. And again, x to the 6th times x to the 6th gives us x to the 12th. Now this is an odd number, so if I do 7 divided by 2, it doesn't work out evenly. However, we can still simplify this. 7 divided by 2 is 3, so y to the 3rd, but there's still going to be 1 left over, right? So if I divide by 2, it's 3 with a remainder of 1. So actually, there would still be a y inside the square root. So if you think about it, y cubed times y cubed times y equals y to the 7th, and we can only take out the perfect squares. So anything that's not attached has to stay in a square root. So when we simplify that, what we're really going to get, these parts in the square root will stay together. So our final answer would be 5x to the 6th, y to the 3rd, and then the square root of 3y. So there's a 3y there. So we took out a 5, we took out x to the 6th, we took out y to the 3rd, and what's left is a 3 and a y. We can do the same thing with the cube root. So look at the cube root, part A. We have this, a to the 6th, b to the 14th. So now 27 is a perfect cube. The cube root of 27 is -3. A to the 6th, 6 divided by 3 is 2, so that would be a squared. And then 14, we can divide 14 by 3, and that goes in 14 divided by 3, that goes in 4 times, but there's 2 left over. So there would be b squared left in the square root. And that, or excuse me, cube root, that's a cube root, so don't forget that. So this would be our final answer for example 1a. So that's how we would simplify radicals. Now we are also going to simplify expressions inside in fractions. So go to page 334, and we're just going to look at example 2a. I'm not going to worry about all the 4th roots and 5th roots. We don't use them that often, so I'm not going to go through examples, and I'm not going to make you do problems with 4th and 5th roots, but we are going to look at cube roots and square roots. So this is the cube root of this expression. And one of the properties we just looked at said that we can split this up into 2 separate radicals. So I can put the cube root of the top over the cube root of the bottom. Now the bottom is easy. The cube root of 125 is 5. This top here, though, like I said, we want to look for, you know how we split 75 into 25 and 3, okay? So if it's a square root, we want to look for square root factors. But if we're taking a cube root, are there any factors of 24 that would be perfect cubes? And there is. We can write 24 as the cube root of 8 times the cube root of 3, because 8 times 3 is 24, right? So cube root of 24 would be the same as the cube root of 8 times the cube root of 3. Well, how does that help us? The cube root of 8 is 2. So we can simplify cube roots the same way we simplify square roots. Just like the square root of 75 would be 5 root 3, the cube root of 24 would be 2 cube root of 3. You guys see that? So cube roots and square roots we can simplify the same way. And again, we want to look for, in this case, perfect cube factors of our number so that we can simplify it. So that takes care of the 24, but then we also have the a to the 6th. So a to the 6th, 6 divided by 3 is 2. So outside the cube root, we would have a 2a to the 2nd, and then the cube root of 3 would be left on the inside of that radical there. And that would be, this would be our final answer. Okay. Adding and subtracting radical expressions. So if we are going to add and subtract radical expressions, you guys learned in algebra that we can only add or subtract like terms, basically. It's kind of like adding and subtracting with variables. So like square root of 18 and square root of 32, they are not like radicals. However, if I simplify, square root of 18 is 3 root 2, square root of 32 is 4 root 2, these are like radicals. So they have to have the same radicands, the same number inside the radicand. And so now if I wanted to add these two, if I wanted to add them, then it's just like it was like 3x and 4x. It would be 7x. 3 root 2 and 4 root 2 is 7 root 2. Okay? So if you can simplify first, and then be able to find that. And then also with multiplication, that's interesting that they went right there. So we'll just talk quickly about multiplication. When we are multiplying, we can multiply numbers outside together, 3 and the 7, and then the 5 and the 2 we can multiply together to get that. We can also FOIL some more expressions, but we'll look at that more with some examples. So look at example 3 on page 335. And we have this expression, 6 square root of 45x plus square root of 12 minus 3 root 20x. And I apologize for the writing, but you can see it on page 335, example 3. So right offhand, these are not the same, which means I can't add them as is. However, let's simplify all these first. So square root of 45, 5 is the same as 9 times 5, and 9 is a perfect square. 20 is the same as 4 times 5, and 4 is a perfect square. This likes to just randomly zoom in on me for some reason. So here we have square root of 9, square root of 5, and square root of 9 is 3, which will multiply by this 6 out front. So that would give us 8, nope, oops, sorry, oops. Okay, thank you. This thing is temperamental. So that would give us 18 square root of 5x. Square root of 12 simplifies to 2 root 3. And this here, the square root of 4, is 2 times the 3 here gives us 6. And then the 5 and the x, the 5 and the x will stay inside the square root. Okay, so now that we've simplified each of these, you should notice that there is like terms here. So we can combine 18 square root of 5x minus 6 square root of 5x, and we just do 18 minus 6 is 12 square root of 5x plus 2 root 3. This one is not like, so it can't be combined, so we'll just leave it like that. So you can only add or subtract if you have like terms, if you have like radicals, and if it's not like at first, you'll simplify each to see if you can get them to be like terms. Now when we are multiplying, so let me see a good one. All right, I'm gonna do example 4, but I'm gonna change it to, I don't know. I guess we can just leave it as is. We'll leave this one as a 5th root. This one's not too bad to work with. So that's negative 10 x squared y to the 6th times 3. Again, I apologize. This does not want to write the best for me. And it was even worse when I tried using my stylus earlier, so I'm using my finger. Okay, so multiplying these, as long as they have the same index, so I couldn't multiply a 4th root and a 5th root. They have to have the same index here. But again, we will multiply the numbers in front together. So we'll multiply the 4 and the 3 to get 12. And then I'm going to multiply the stuff inside the square roots together. So negative 10 times 16 is negative 160. X to the 2nd times x to the 4th would be x to the 6th. Y to the 6th times y to the 4th would be y to the 10th. And now, so again, just multiply the numbers in front, multiply the things inside, and now we can simplify this a little bit more. So are there any perfect fifths factors, like 1 to the 5th, 2 to the 5th? This one's not, this is why we're not going to work with these too much, because I don't expect you to know your perfect fifths. But we do have 2 to the 5th. One factor of 160 is 32. So this is the same as 32 times 5. And 32 is 2 to the 5th power. So I can take a 2 out of the square root. There would be a 2 to the 5th times 5. Oh my goodness, this is horrible. And so the 2 to the 5th would come out, the 2 would come out, and the 5 would stay in. X to the 6th divided by 5, 6 divided by 5, 5 goes into 6 once. So x to the 5th times x to the 1st is what this would be. So this will come out, and this will come out. And y to the 10th would be 10 divided by 5 divides evenly, so y squared would come out. So we have 12 times this 2, which is 24, and then the fifth root, oh, sorry, also the x comes out, so let me write that over here, 24x, and then y squared, and then we have the fifth root. What's left inside is the 5 and 1x, and that would be our final answer. So it's a lot of simplifying in this case. Oh, and there was a negative there, so I should have taken that negative out as well. Negative 2 to the 5th can come out there. Okay, the other thing we can do is multiply expressions. So if you look at example 5, I'll go over here. Let's just look at this one really quick together on here, and we'll set it up, and then I'll solve it, and then we'll stop there. We won't finish this whole section today. It's kind of a lot. So example 5 here, a sports pennant has the dimensions shown. Find the area and square inches of the pennant. So this is a triangle. Area of a triangle is half the base times the height. So the area would be half of the base, which is this distance, times the height. Okay, so if we're working that out, half the base, which is 3 root 8 plus 4. Oh my goodness, you guys, I apologize. This is so frustrating when it doesn't want to work very nicely. Times 7. Okay, let's see if it'll work better over here. Maybe it'll work better over here. Okay, let's see what we got here. All right, so 3 root 8 plus 4, and then here we're going to put 7 root 8 plus 6 root 3, which is this expression right here. Okay, so now if we want to multiply that, we're actually foiling that out. So 7, this thing hates me so much. Okay. Oh my goodness, I'm so sorry. All right, I'm gonna have to just use what they have because this is not working. So just imagine the 7 root 8 plus the 6 root 3. So when we FOIL, first, outer, inner, last, it would be the 3 root 8 times the 7 root 8, which is right here. Then the 3 root 8 times the 6 root 3, which is right here. Then the 4 times the 7 root 8. And then the 4 times the 6 root 3. Okay, so again, I don't like how they have done this, because if we just simplify each term, 3 times 7 is 21, 8 times 8 is just 64. You don't have to write it as 8 squared. 3 times 6 is 18, 8 times 3 is 24, 4 times 7 is 28, root 8, 4 times 6 would be 24 root 3. And then all we're going to do is simplify each of these. So 8 can be simplified to 2 root 2. So this is the part maybe where I'll write it. So once you get here, okay, so square root of 64 is 8. So 21 times 8, what is 21 times 8? 168. I know that. I don't need a calculator. But it's late at night while I'm recording, so maybe I do. Square root of 24 factors, perfect square factors, would be 4 and 6. So this would be 2 root 6. So 18 times 2 is 36 root 6. Here, square root of 8 is 2 root 2. So 2 times 28 is 56 root 8, or root 2, sorry, plus 24 root 3. And there actually is nothing in common there. There's no radicals that are in common, although, yeah, sorry, I can't. My apologies for how awful this looks. So when we simplify this, it's just, oh, and then we have to multiply that all by 1/2. So if you take all these values and multiply it by 1/2, then half of 168 is 84. Half of this will be 18 root 6. half of this will be 28 over 2, and half of the last term that I couldn't write would be 12 over 3. So hopefully that wasn't too bad for you guys. We will save the rationalizing the denominator, the division part, for the next lesson. I'll just kind of rearrange things because I think that's enough for today's notes. And it would be probably a good idea for you guys to, from examples 1 through 5, do the check problems for each of the examples 1 through 5. That would give you good practice before class tomorrow, where we work on some of these problems. So that's all we have for today. Enjoy the rest of your online day, and I'll see you later.